Okay, so we have a data set like this. This is a company called Genetech. So we have its sales data from 2015 to 2019 by region, by product, etc. So our task here is to create a quarterly forecast of demand for 2020 and also measure the accuracy of our forecasting model using MAPE for 2015 through 2019. First of all, I'm going to create a pivot table to look at the data. Year, quarter, demand, in total, change it to sum. Now let's insert a pivot chart. This demand. Okay, so now let me remove the blank. Okay, so overall speaking, it seems that there is some seasonality, a repeated pattern here. So the demand in quarter 2 and 4 seem to be higher. Demand in quarter 1 and 3 seem to be lower. But if we look at data in the yearly level, aggregated level, we find that it seems that there is a trend too. There's an increasing trend. So what we are looking at here is a demand where it has a trend, an increasing trend, and also seasonality within each year. So annual demand is increasing, but quarterly demand also presents seasonality. Now we're going to make a forecast for 2020 and also break down the forecast of 2020 into quarterly forecast in 2020. So this takes 2 steps. First, we're going to use a regression forecast to forecast the annual demand in 2020. Second step, we're going to break down the annual demand forecast in 2020 into quarterly forecast in 2020. So for more detail, please refer to slides. Here I'm going to focus on how to make this happen. Okay, first, so let's create a annual forecast for 2020. So let me copy this data over here first. Let me paste the value. Okay, so we'll have annual demand, and we're going to have a forecast demand here. Okay, let me adjust the format. We're going to create a demand forecast. Okay, so we're going to create a regression forecast using time, in this case year, as an independent variable to forecast the dependent variable, which is the demand in a year. In a regression forecast, we need 2 things. We need a slope and an intercept. Okay, so we're going to create a slope using the function called slope, S-L-O-P-E. It asks for 2 inputs. Known y's is the dependent variables that you know, which is the historical annual demand. Known x is a time index, which is simply the year in this case. Okay, that's it. Intercept is simply intercept, using this function with the same parameters, known y's and known x. Okay, now we can generate the forecast. So with this formula, what it tells us is that, well, the annual forecast y equals to our slope, which is, equals to our intercept plus the slope times the time index, which is the year. So we're going to use that formula here. So equal to the slope, we're going to put the $sign to fix the reference, plus the slope fix a reference times the time index, which is year. Okay, we drag it down, and this is our demand forecast. Apparently, we cannot allow for fractional demand, but for the sake of this example, let's assume that we can take fractional numbers. We can have 0.2 demand, just for illustration. Okay, so here's the first step. Now we know that the demand forecast for 2020, actually, we can drag it down here, would be this number. That completes the first step. And now we are going to use this number as an input and break it down to quarterly forecast for 2020. Okay, to do that, let me reorganize the data here first. I am going to copy this over here. Okay, just copy the value. Quarter one. Okay, so now again, we have quarterly demand, historical demand for the past 5 years. First, we're going to see what is the average quarterly demand. Okay, it's simply the average of the demand in a year. So this 2404 means that on average in 2015, every quarter has a demand of 2404. Okay, of course, this is average without taking into account any seasonality. Now, the second step is to calculate something called seasonal index. If you don't know what is seasonal index, please refer to my slides. Okay, seasonal index for each year. Seasonal index for each quarter of each year is simply the actual demand divided by the average demand in that year. Okay, I'm going to fix the reference to this 22. Okay, now I can track it down. You can see that seasonal index is the actual demand divided by the average. So I'm going to do the same for all of the years. I check that my equation is correct. Okay, so what it means here is the following. Changing the percentage. So in 2015, quarter one demand is 71% of the average quarterly demand for this example. Second quarter of 2016 demand is 109% of the average quarterly demand in that year. Okay, so seasonal index captures the degree of seasonality of a quarter. Now I'm going to calculate something called average seasonal index. This is simply average of all these seasonal index for the same quarter across all years. 78.1%. What it means is that on average in the past, quarter one demand has been around 78% of the quarterly average. So on average, quarter one demand is about 71% of the average quarterly demand. And likewise, we have every seasonal index for every quarter. Now, we are ready to make a forecast. Okay, so with that, we can make a forecast for 2020 for each quarter of 2020. Okay, So for 2020, let me put 2020 here. First, the average to perform the forecast, we simply multiply this average seasonal index by the average quarterly demand. So average quarter demand. This is simply taking the annual demand and divide by 4 because we have 4 quarters. Okay, so on average, each quarter in 2020, we have 3,400 of demand. But this is without seasonality. Now we need to restore the seasonality. So the final forecast is simply the average quarterly demand times the average seasonal index to restore the seasonality of each quarter. And this is the final forecast for demand in 2020. Okay, so that's the second part of our analysis. Now we finally have a forecast for quarterly demand in 2020. That's great, but how accurate is our forecasting model? Well, to see that, we can apply this same model back to forecast for every quarter in 2015 through 2019 and see how accurate it would be if we are using it to forecast in the past. Okay, to do that, I'm going to reorganize the data a little bit. Okay. So I'm going to copy all of the historical demand by quarter to here. Okay, so this is the demand, and I can also put the year and quarter. So apparently I copied this from somewhere else just to save time. And we can apply the same analysis to perform the forecast, which is the every quarter demand times the average seasonal index. Okay, so first the average quarterly demand is simply the total demand divided by 4. Okay, so it will be simply the average of the total demand However, this is incorrect because I'm using the actual data, so this is a common mistake. When you try to make a forecast, the every quarter demand need to be the average from the forecast, which is this number. So it actually should be this number divided by 4. Okay, so every quarter demand is from forecast. So I'm going to use this number for the following 3 quarters. So this is the forecasted average quarterly demand. Okay, likewise, we're going to create same thing, but now for 2016. I'm just copying the formula and change the reference to the right number. Okay, so I have the quarterly demand over here, and I forget to divide this by 4. Okay, so let me fix that. Okay, so this is the forecast of every demand per quarter. And now let's copy the every seasonal index. Okay, so every seasonal, okay, it's just those numbers. Okay, I'm just copying the value over here. Change them to percentage. You'll see that it's the same number here for each quarter. And finally, the forecast would be the average quarterly demand from forecast times the every seasonal index. So that's it. Okay, so this would be our forecast for the historical data. Now we can compare our historical forecast to the actual demand and see how accurate our forecast is. So we're going to use MAPE to measure forecast performance. To use MAPE, we need to calculate something called absolute error. So that's the absolute value of the difference between our actual demand and our forecast demand. So the function ABS gives you the absolute value. Okay, double click it, absolute error. And now based on that, we need to see what's the percentage of error we have. So absolute percentage error, which is simply dividing our error dividing our error by the actual demand. This is roughly 7%, close to 7%. That means that our forecast is 6.7% away from the actual demand in the first quarter of 2015. So with that same formula, we drag it down so we know how much error we would make. Okay, then MAPE is simply the average of all of those numbers, which comes out to 7.36%. What it means that if we are using our model to forecast in the past, our average error per quarter will be 7.36%. So our forecast is 7.36% off from the actual demand.